that when we are navigating, we need frequent plotting of our position so that we know that we are always on the track. So let us say if this is your coast, and this is the path which you have to take, and there's a lighthouse, let us say over here. There may be a light over here, whatever. So our objective is to find our position so that we don't get too close to the land. So what we will do generally, we will take one bearing, we will take another bearing, and we will get our fix like this. So then we can do our course correction, come back on the track. Maybe I need to alter course a little bit like this. Maybe I would like to remain south of the track all the time. It depends how I'm navigating. So you have a chart in front of you, either a paper chart or like this, whatever. And you can plot on the chart and you can compare the land and you can see everything, whether you are safely navigating or not. But the point is, when you move away from the land, at sea you can't see the land. So you don't know what bearing to take, how to plot a position. You have a chart in front of you, the land may be very far. Or you may be deep in the ocean without land on the chart also. So in such cases, if we don't see anything, if we don't have anything to guide us, how do we plot our position? So out at sea, do we have anything to guide us, gentlemen? What other options we can take apart from the electronic? Forget the electronic for some time.
Sir, can you just repeat the question?
Out at sea, deep in the ocean, how can we plot our positions? Do we have anything to guide us? Since I cannot see any land, lighthouse, anything.
So sun, moon, stars.
Sun, moon, stars.
Yeah, I can see the sun, the moon, the stars, the planets, depending on the time of the day. And navigators found that, okay, since we can see something, why don't we find some method? Why don't we find some method how to use these heavenly bodies to plot our position on the earth? But there was a very big question. When you are plotting a position like this, the way I have shown on the board, the lighthouse or the light or the building or the mountain is marked on the chart. Some hydrographer or someone has studied the area, the water, the depth, the islands and everything, and made those charts. So you have a reference point. You know, in this chart, if you can see these two targets or objects, and if you take a bearing, you will be able to find a position. The object is also on the chart. You are also on the chart, and the chart is made in the same way as it looks outside. The shape of the land is the same as the shape on the chart. That is what the projections are all about, whether it is Mercator or whatever. So the whole idea is so that you get your correct bearing. The shape on the chart should exactly match with the shape outside. So now if I am having a chart where I cannot see the planet or the sun or the moon, how will I draw a bearing? Imagine you are in the ocean and you have a chart with water all around you. You said you can use the heavenly bodies to plot a position, but you cannot see the heavenly body on the chart. So from where will you draw the position line, the bearing? How will you know the position? So are you understanding the problem we are discussing? I have decided to use the heavenly bodies. I have a chart with me, but just like the lighthouse and the mountain on the chart, I cannot see the heavenly bodies on the chart. So that is the problem in front of me. Is it clear to everyone?
Yes, sir.
Yes.
Okay. Now, the question came, why don't we establish some sort of a relationship between the heavenly bodies and the earth? If I can find some connection between the heavenly bodies and the earth, then maybe I can find a solution. By now they had realized that the earth is rotating, the sun is moving from one side to the other side, east to the west, moon is everything is rising in one direction and setting in one direction, which means the earth is rotating west to east, bodies are rising in the east and setting in the west. So there is a pattern which people started studying, and over centuries they realized that certain bodies move in certain fashion. The sun moves in a typical fashion, the moon in a different, planets differently, stars of course don't move at all, even though they rise and set, but their position in the sky remains the same. If you are also in the same position, when you are moving, of course, is different at sea, but stars also remain in the same. But in space, they of course don't move; they remain where they are. Relatively they might look, yeah, because if you are in the northern hemisphere, southern hemisphere, you will see different type of stars. The altitudes will be different, the angles will be different. So those things will be there. So slowly a pattern was found, and they tried to establish a relationship between the heavenly bodies and the earth. So what is that we will study today. Before that, I will like to tell you a little bit of astronomy again, which will give you an idea of the size, distances, and what we are talking about. All of you know that Earth is a planet, there is a solar system, and solar system belongs to the... Where does the solar system belong to? Pardon? Louder, everything louder.
Milky Way galaxy.
Solar system belongs to the Milky Way galaxy, correct? Yes or no?
Yes. Yes,
Our
sir.
galaxy is formed, you know that? A Big Bang theory.
Yes, sir.
So different types, different shapes. So what are these galaxies? You see the Big Bang theory, matter was formed, gases solidifying. All these galaxies are very big and they are expanding continuously. They are moving away from some center. They are continuously expanding. You are able to see the board and what I have drawn?
Yes, sir.
Color is giving little problem. I'm putting so much in, but it is not coming. Okay. What is the name of our galaxy? The Milky Way. Milky Way. Now, let us say this is the Milky Way, and this is the center of the Milky Way. Our solar system is somewhere here. You can see this red dot.
Yes.
That is our solar system. I've drawn
Yes.
the dot a little big for you to see, but actually it is much smaller. How big is the galaxy? The length of the galaxy is about 100,000 light years. Light years. How much is 1 light year? Light travels at the speed of 186,000 miles per second. In 1 year, light travels 6 million miles. 6 million. In 1 year, the light travels 6 million miles. The length of a galaxy is about 100,000 years. So you can imagine the distances and the size that we are talking about. The Milky Way galaxy is also very big. Like this, you know how many galaxies there are in the universe? There are millions of galaxies. 1 million is 10 lakhs. There are there are billions of galaxies, not millions, billions. And in every galaxy, there are millions of stars. What this red dot I have drawn is the sun or the solar system. Entire solar system or the sun is just a small speck, a dot. This is one star. Sun is one star. Like this, there are millions of stars in the Milky Way galaxy. And when at night, what you see outside the stars are only the stars in our galaxy. We cannot see the stars in the other galaxies. We can see only the stars in our galaxy. The solar system is about 30,000 light years from the center. 30,000 light years from the center of the universe. And this entire thing is also rotating. Which direction? This entire thing is also rotating. So even though we say the sun is stationary, because it appears stationary to us, the entire solar system and the entire galaxy is also moving about its center. Everything is moving. But because it is relative motion, it appears stationary to us. And how long does this one revolution take? Anyone has any idea? If you have read the book, you will know. 200 million years. So in 200 million years, the solar system would have taken one complete. Why are we talking about all this? Just to give you an idea. The other day when I was talking about a star in space, very distant, I wanted you to imagine how far it is. I don't know whether you could imagine or not. I told you the Earth, the distance between the Earth and Sun is 93 million miles, which is very small. Now you can imagine that dot itself is the entire solar system. Light travels at the rate of 6 million miles per year, which is the closest star that we can see. Which is the closest star, gentlemen? Anyone has any idea?
Sirius.
Proxima Centauri.
Closest star.
Sirius, sir.
Sir, Proxima Centauri.
Rizal Kent. It is also known as Alpha Centauri. How far is it? 4.3 light years. Into 4.3. So you can imagine how far on the one hand we are talking only of 93 million miles, the sun. And on the other hand, we are talking the closest star 4.3 light years, 4.3 into 6 million. So you can imagine how close the sun is to us. So the whole idea was to give you an idea of what we are talking about. We are a non-entity in this universe, very small thing. And Stephen Hawking says maybe the idea of universe is old-fashioned. Maybe it is multiverse. There are more universes like this. So whether we should call it a universe or a multiverse, I don't know. But the whole idea is that we can see only the stars in our galaxy. Now, where is the center of the whole thing? How do I start my calculations? Where is the center of the whole thing? We cannot say what is the center and where to start. So we have found a very easy method. I cannot say just because I can see only the stars of my galaxy, I will take the center of the galaxy as the center. I cannot say I will take the solar system as the center. So I have found another easy way. I will say I am the center of the universe because I can see all the heavenly bodies in all directions. If I look north, south, east, west, I can see sun, moon, stars, planets. And since I want to find out my position, let me be in the center of the universe or my calculations or whatever. Is that idea acceptable to you all? Yes or no?
Yes, sir.
Since I am interested in my position only, so let me consider only the heavenly bodies that I can see. If I can see only the heavenly bodies inside my galaxy or all the stars of my galaxy only, so let me be concerned with what I can see and let me forget what I cannot see. And let me consider myself as the center and let me try to figure out how to go about now. Okay. So let us say this is the Earth. It might be a little small. Let us say this is the Earth. I am an observer. Somewhere on the Earth, I can be at the North Pole, I can be at the South Pole, I can be any point on the Earth. I will talk about that later. First, we will establish a relationship between the Earth and what we can see around us, because I would be standing somewhere on the surface of the Earth. So this is the Earth and this is the center of the Earth. And this we will consider to be center of our universe. I said I will be in the center, but when I am in the center, I may be at any point on the globe. But the angles that we measure, I told you earlier, of all the heavenly bodies are between the centers of the body. So from the center of the Earth to the center of any heavenly body, we measure all the angles. Now, there could be the closest is the moon. There could be a moon here. Little far is the sun. There could be a sun here. There could be a planet somewhere in between here. And there could be a star. Star is very, very far off. Closest star 4.3 light years. Let us say this is a star here. Now what happens? When I look in the direction of the star, I can see the star somewhere here. When I look in the direction of the moon, I can see the moon somewhere here. When I look at the sun, I can see the sun in this direction. When I see the planet, I can see the planet in this direction. Can you tell me, by looking at any of these four heavenly bodies, can I judge how far it is? Can I judge how far it is?
No, sir.
I have no means of judging how far it is. To me, they all look same distance, as if they are all projected on a screen. Has any one of you been to a planetarium? Nehru Planetarium in Delhi, Birla Planetarium, Calcutta, Bombay, everywhere there's a planetarium nowadays. Even in small towns we have. Anyone has been on a planetarium? No one has been to a planetarium?
No, sir.
I'm surprised, gentlemen. Whenever you get a chance, go have a look. What do they do in the planetarium? You are seated It's a circular hall. You're seated over there. Your seats are inclined. You're looking up to the sky. There is a projector in the center of the hall. In a cinema hall, it is different. All of you are facing front on the screen. Projector is at the back. But in this case, it is different. Projector is in the center. There is a screen on top. Your seats are inclined. You're looking up. How is the screen on the top? What shape is it? By now you must have got an idea of what I'm saying.
Dome.
Dome like, sir.
It's like a dome. Because from the center of that projector, it has to be equal in all directions. Otherwise, there will be distortion. It is like a dome. So at night, if you have seen the sky above your head, you must have realized that you are looking at a dome and you are looking only at half of it. Let me see if I can draw it over here properly. Actually, on the big board, it is slightly better, but I hope it is okay. So, have you anytime been on the roof of your house or someplace? You lie down, keep looking at the stars, or nighttime in the ship also. You can see all around you and you can see above you. What shape would you give it? Would you give it the same shape as the planetarium, like the dome? Yes? Or no?
Yes, sir.
Let me draw the Earth. Let us say this is the Earth now center. Better to understand. So that is the celestial sphere we are talking about. Wherever the heavenly bodies are, whether they are close to the Earth or far from the Earth, when you look at them, they are all projected onto the screen. So the celestial sphere is a sphere of infinite radius. I will show you a picture now, which will give you an idea of what I am talking about. And then it will be easy for all of us to understand. Can you all see this lady holding that globe?
Yes, sir.
Yeah, slightly bigger now. Okay. You can see it is a transparent globe and the Earth is there in the center. All of you can see that blue Earth in the center? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
This is what I'm trying to show. The Earth is in the center. The center of the Earth is the center of the celestial sphere. And you can see different lines and all drawn over there, which we will discuss. There are heavenly bodies within the celestial sphere. But if someone is looking from the Earth, he will see all of them projected onto the screen, which is the celestial sphere. Have you all got an idea of what I'm trying to say? So I will remove this picture now. And we will come back to our screen. So remember earlier what I was trying to tell you. We are trying to establish a relationship between
सर आपकी वॉइस में डिस्टॉर्शन आ रहा है.
distortion है.
Yes, sir.
I think it will
Yes, sir.
settle down. The signal is okay. We are trying to establish a relationship between the earth and the heavenly bodies, so that we are able to find a system or method of finding our position by taking help of the position of the celestial bodies. So if I know the position of the celestial body and somehow I bring the celestial body down to earth, let us say if I am able to bring down the sun, the moon, the planet and stars onto the earth, and I am able to take a bearing, I will be able to get my position. So we are all working towards that. So first let us try to find the relationship between the earth and the celestial sphere. So earth is rotating on its axis, we know. So I am keeping the earth upright. So if this is my north pole, if this is my north pole, I will not write too much over here. You try to figure out, understand, or refer to some book in the diagram because it will become a little hodgepodge. So if this is the north pole over here, and this is the south pole, this is the center of the earth. If I draw a line joining south pole to the north pole through the center of the earth, and I extend it in both the directions, it will go and touch the celestial sphere here, which we will call the celestial north pole. Similarly, there is a celestial south pole down below. Celestial north pole, celestial south pole. Now these are all imaginary points which we are building up for our reference. There is an equator on the earth. There is an equator on the earth. So if I extend the equator onto the celestial sphere, I will get the, what do I call this? Equinoctial. So just like the equator divides the earth into two hemispheres, northern hemisphere and southern hemisphere, the equinoctial divides the celestial sphere into two hemispheres, the northern celestial sphere and the southern celestial sphere. So far, gentlemen, is it all clear? Anyone has any questions, any doubt?
No, sir.
Very good. The earth rotates west to east. Earth rotates west to east. So how does it appear to us the celestial sphere is moving in which direction? So how does it appear to us? The celestial sphere, if you look at the sky, all the bodies are rising in the east and setting in the west. So the whole celestial sphere appears to move east to west, which means if there is a heavenly body which is rising in the east, let us say here, this is the heavenly body rising in the east. As the earth is rotating, slowly, what will happen? This body will rise and it will set in the west. That will be the path taken by the body. It will rise in the east and it will set in the west. Now you notice that the distance of the body from the equinoctial towards the northern hemisphere is almost the same when it is setting. There could be another body which is rising here. And it could be setting here. What is the difference between these two bodies? There is a body which rose here and set on this side. There's a body which rose here and set over here. What is the difference between the two bodies? Anyone can tell me? Pardon?
सर एक इक्विनॉक्शियल के ऊपर हो रही है और नॉर्दर्न इक्विनॉक्शियल के नॉर्दर्न में
Yes, very good. One is above the equinoctial, one is below the equinoctial. So the above the equinoctial body, I would call it saying having a north declination. The body which is above the equinoctial, it is having a northerly declination. Because this is the northern celestial sphere, this is the southern celestial sphere, and this body is having a south declination. So how do I compare with this to a similar line on the earth? How do I compare this with a similar line on the earth?
Parallel of latitude.
Parallel of latitude, very good. So there are parallels of latitude on the earth. North latitude, south latitude. So we have found some sort of a relationship between the path of the heavenly body, which is similar to a parallel of latitude on the earth. So if I know the declination of a body, and I want to bring it down to the earth, where will it come? It will come on that same parallel of latitude. Yes or no? Because this is also divided into 90 degrees and the earth is also divided into 90 degrees. They are concentric spheres. The center of the earth, I said earlier, is the center of the celestial sphere. So our earth and the celestial sphere are two concentric spheres. So everything on the earth is projected in a similar fashion onto the celestial sphere. So a body which is rising on the equinoctial and setting on the equinoctial will have how much declination?
0.
0. The sun has 0 declination on which 2 days?
Tropic.
Which
First
2
point
days?
of Aries, first point of Libra.
2 equinox. 2 equinox. 23rd, 21st March or 23rd March and September. It has 0 declination. So those 2 days, the sun is rising on the equinoctial and setting on the equinoctial. That is why we have equal days and equal nights in all parts of the world. Other days, whenever sun is having northern declination, sun is rising a little above the equinoctial and setting like this, till it reaches the Tropic of Cancer, 23.5 degrees. And then 23.5 degrees, maybe the sun will rise like this and set like this. Then it starts its downward journey again, rising here, setting, rising again. It comes to the other equinox, autumn equinox, and then it goes on a south declination till it comes 23.5 degrees south, and then this is the path of the sun. So any question, gentlemen, so far? Have you understood how the body rises on the celestial sphere and how it sets? Depending upon the declination, north declination bodies will rise north of the horizon, north of the equinoctial, and south declination bodies will rise south of the equinoctial. This point is very important for you to remember when we discuss amplitudes, rising bodies, azimuth, and when you have to think, apply your mind. When all the information is not given in the question, sometimes you have to apply your mind to see how the body is rising, how it rose, what was the angle at what it rose. Then you will know exactly what we are talking about. So this part is clear, gentlemen?
Yes, sir.
Okay. So now I have got one reference point. Depending upon the declination of the body, I can find out its latitude position on the earth. Where are the declinations given, gentlemen?
Nautical almanac.
In the nautical almanac, huh? All the heavenly bodies that we are concerned about, sun, moon, the planets, the heavenly, all those heavenly bodies that we use for our navigation, sun, moon, and the 4 planets. Which are the 4 planets that we use? You all must have seen the almanac sometime. Which are the 4 planets that are visible to us clearly and the ones that we use for navigation?
Venus,
Mars,
Mars,
Jupiter,
Jupiter,
Saturn.
Saturn.
Venus, Mars, Jupiter.
Venus, Mars, Jupiter, and
Saturn.
there is one more,
Saturn.
Saturn.
Saturn. So from now on, do one more thing, gentlemen. Keep the almanac handy with you, whenever we are discussing, because I might need you to refer to the almanac quite frequently to collaborate our information. So those 4 planets are there. You will find all the GHAs and everything. What about the stars? What information is given for the stars? Is it the GHA or something else?
SHA, SHA and declination.
For the stars, SHA is given, not the GHA. So we'll try to figure out why SHA is given and not the GHA. We will see that. Stars, I told you, are so far away that even if they are moving, we cannot see. In the first diagram, when I showed you, the solar system is a dot. So if somebody in my galaxy is trying to see Earth in that small dot, will he be able to see whether Earth is moving or not? Yes or no? Within that dot, if you are moving, the bearing will remain the same from how far you see.
Yes, sir.
So that is the point. That is why stars are so far away. We say stars are fixed objects in space. Because even if they are moving, making big circles in their solar system or whatever, we do not see that movement. They are so far away. You can, in a day-to-day example also, you can see if somebody is standing next to you in your room and is going around in circles, you can see he's going around in circle. But if you look out of the window, half a kilometer or 1 kilometer away, and if a person standing there is going around in circles, will you be able to make out? You will not be able to make out what he's doing, whether it's going around you. For you, it will look as if he's there only, standing there. Similarly, like this, 1 kilometer is too far off. If someone is 10 kilometers away and going around in circles, and if you can see him through some binocular or whatever, you will not be able to see whether he is going around in circle or standing in one point. Okay, so we got one reference point. Now, what is the other reference point which we are looking at? What is the other reference point that we are looking at? To find a position, what do we need? Latitude and
Longitude.
longitude. So we need another reference point, how we will go about. For the declination, and latitude we had a reference point called the equator and the equinoctial. So north of it and south of it we were able to figure out. Now for the longitude, let us find out what do we have.
Meridians.
So on the earth we have a point called Greenwich near London. You know that, no? So on earth we have the Greenwich meridian. On earth we have the Greenwich meridian. If the same meridian I project on the surface of the celestial sphere, I will get a meridian running from the celestial north pole to the celestial south pole. Am I right?
Yes, sir.
So I have got a celestial Greenwich meridian. Celestial Greenwich meridian. So anything to the west of the Greenwich meridian I can measure, and anything to the east of the Greenwich meridian also I can measure. I've got a reference point now. Yes?
Yes, sir.
So let us say there is a star here. Let me put it here only. Let us say this was a star over here. And I make a meridian passing through the star. Is it clear or no? This blue color, I don't know. Let me do it with black ink. I think I will remove these extra lines so that you don't get confused. So let us say is it okay now? So this was a star here. I make a meridian through the star. I can make a meridian through any point on the celestial sphere because it is also a great circle. So a point which is passing from this point goes down to the celestial south pole. This is a meridian. The green one is the Greenwich celestial meridian. And the passing through the star is this meridian passing through the star. Similarly, I can have the sun somewhere here. I can have the sun somewhere here. I can have a meridian passing through the sun. And then I will be able to measure the angle from the Greenwich meridian. So let us say I take Greenwich meridian as the reference point 0, and I want to measure how far the star is the angle. Can you see this distance with the arrow I have drawn from here to here? This I will call the Greenwich hour angle of the star, GHA star. So how do I define the GHA? Are you all able to see this and you are able to understand what I am drawing? Yes? The green one is the celestial Greenwich meridian. The black one is the meridian passing through the star on the celestial sphere. You have to imagine, use your imagination, like a cage. All of you must have seen a bird cage with wires. Yes or no? पिंजरा देखा जिसमें बर्ड होता है छोटा सा?
Yes, sir.
Yes, sir. देखा
गोल पिंजरा, ऊपर का पोर्शन गोल होता है, नीचे फ्लैट होता है ना. So like this, imagine half of the पिंजरा we are seeing now from the top. Wires come from the center where the hook is there to hold from the center to the flat portion where the bird is there or the platform is made. Yes or no? You can imagine a cage, not a difficult thing to imagine. Yes or no?
Yes, sir.
Yes, sir.
So these are all wires of the cage. One wire is the Greenwich meridian. The other wire is the meridian of the star. Like this, you know, for every heavenly body we can have a meridian. I give you another example of the sun. Meridian passing through the sun. What is that meridian? It's a semi-great circle, imaginary line joining from the celestial north pole to the celestial south pole, passing through that body on the celestial sphere. Just like we were measuring longitude, now I am trying to measure the distance from the Greenwich meridian of the other heavenly bodies. That is called the Greenwich hour angle. Greenwich hour angle is the arc of the equinoctial. This is the equinoctial, arc of the equinoctial or angle at the pole. So either you measure this arc or you measure this angle. It is the same thing. Greenwich hour angle is the arc of the equinoctial or the angle at the celestial pole between the Greenwich, celestial Greenwich meridian and the meridian passing through the body, whichever body, measured westwards. You must always remember that we are measuring westwards. Measured westwards. Have you all understood this line so far? Yes or no? So if you have
Yes,
been
sir.
able to understand this picture, what are these meridians comparable to on the earth? I can call them the meridians of longitude. Yes or no? The celestial meridians are similar to the meridians of longitude on the earth. Correct? Are you there, boys, or no?
Yes, sir.
Yes.
So are you agreeing with me or no?
Yes, sir.
Yes? Are you agreeing or no?
Yes, sir. Meridians are the projection of longitude.
Yes, sir.
So in this case, when I'm saying measured westwards, this angle is about, let us say, 10 or 20 degrees. But if I have to say the GHA angle of the sun, then how will I measure? Measured westwards. So the sun meridian is here. I'll have to go right around like this and come here. If I say the angle will be like this, going right around. Sorry, not from here. Going right around and then coming back here. So what do you do? Let's go for our break now. 15-minute tea break. I'll keep the picture as it is and I will ask you questions about the longitude. Very interesting phase you are entering. Don't lose your focus because understanding the celestial sphere is very important. Once you understand this, you will be able to solve any celestial navigation problem even up to phase 1 level. You will not have a problem, but the basic point is you must understand the celestial sphere very, very clearly. So, right, gentlemen, you can go for your break now.
Thank you, sir.
Come back after 15 minutes.